Okay. Awesome. Good day, everyone. Good day, good evening, good morning, wherever you are in the world. Welcome to another Microsoft Excel section. So for today's session, we're having data manipulation using Pandas. And our special guest goes by the name of Bunmi Akinremi. So our company, UrBizEdge. So UrBizEdge is a registered Microsoft Excel consulting, financial modeling, business intelligence, data analysis, and enterprise solution firm in Nigeria. Also, we specialize in helping companies and high-value professionals be on top of their business data. So as you all know, we're also a training company here in Lagos. I also have some branches in Abuja and Port Harcourt. So this is our calendar for our upcoming training. On the 27th to 28th of May, we're going to be having big data analysis, Power Query, Power Pivot, and VBA in Excel. That's Visual Basic Application. Also on the 28th to 29th of May, we'll be having Advanced Financial Modeler and also a mock exam. So I'll give a brief description about our special guest, who goes by the name of Bunmi. So Bunmi is passionate about bringing AI research into industry to solve human problems. She specializes in computer vision, leverages various machine learning and deep learning algorithm and GPU to get faster computation and give faster results. She's also a GitHub campus expert and also a public speaker. So you can follow Bunmi on Bunmi Rose_Rose, and I will also give. She also has a LinkedIn, a Medium blog post. I'll also give you a LinkedIn profile. So without no further ado, I want to invite the section to Bunmi. So Bunmi, over to you.
Thank you so much for the warm welcome. Okay, I hope everyone can hear me.
Yeah, you can hear you.
Okay.
So I'll stop sharing my screen.
Okay, so give me a minute. Let me quickly share my screen. Can everyone see my screen?
Yes.
Okay, this evening I'm going to talking to you guys about data manipulation with pandas, right? So I'm going to assume probably you're a bit familiar with Python, but even if you're not, it's fine, right? So I'm actually doing a lot of beginner work today, so it's fine for me. So yeah, let's get started. So yeah, you already give a lot about me. So just three things: data science, a community advocate, and then I'm also a writer. So three things to describe me. So today I would give a quick overview of what pandas is and how some of the functions you use in pandas in Excel, right? How you can import them to pandas, right? So would I say connections between pandas and Excel, and also I'm going to do hands-on session. So I'll show you how these functions work and how you can actually write codes, with pandas and all. So it's not just going to be theory. Yeah, it's not a theory session. Okay. So what is pandas? Pandas is actually an open source tool. Like that's the great part of it. So you can contribute to it. You can add a very interesting function you feel should be part of it and all. And then it's fast, it's flexible, it's easy to use because it was built on Python, so it's very easy to use and it's a great tool for data analysis and manipulation. So anyone getting into data science or data analysis is like, oh, import pandas, import numpy and all, because it's actually a very great tool. Not like there are no others, but then it's very beginner friendly and it's something you can learn like very fast and become very proficient in it. Okay, so some similarities between pandas and Excel, right? So in Excel, I know that you have like this worksheet, your work table, right? And then in pandas, you call it data frames or you call them data sets. So in Excel, you have like a worksheet and then you have these columns, you have rows and your data is in there, but in Pandas we call them data frames. In general data science world, we call it data sets, And in Excel, you have columns, right? You have rows. In Pandas, we call them series. So they are not, it's not like another new word or new kind of face or something. It's just how Pandas kind of interpret them. And I'll actually show us that later. So you also have row headings like the title of each row. So in your Excel sheet, right? So you'll be having, maybe you have like about 7 columns. Then there is this would I say index? Okay, let me not say index, where you kind of number each row. I guess that's what it's called. It's called index, right? So you have for me for the first row 1, then all other information, then for row 2 all other information, so something like that in your Pandas data frame. So a row is a row in Pandas or in Excel, and also in Excel you have empty cells, right? But in Pandas we denote them as nans, NANs, right? So maybe as we are walking through, if you get to see any end somewhere, don't like that it just means that that particular um data column or data row is empty. So these are just some of the similarities, like just these are just like general terms. I'm going to show us how to do manipulations like filtering, which I'm sure some of us may be excited about, like how to do filtering, how to merge two data sets together, or would I say I won't say two Excel worksheets together, how to um group, do aggregates, do additions and all kind of stuff, easy stuff with Pandas. But the thing I love about Pandas is that it actually allows you to do way more complex things. Yes, Excel is awesome, yes, but I feel more comfortable using Pandas if I'm working with very large data sets, right? And then I'm kind of building a pipeline. So each of them has like their own use cases and use scenario. Excel is good if you want to like get insights like ASAP. Okay, you want to like quickly submit a report, you want to generate a dashboard or something like that. But then Pandas is if you're looking into building something more than just a report, right? You're looking into building an end-to-end solution, right? You will not actually not want to use Excel for that, right? Excel has its own like very very great use case for for reports and all those kind of things, right? So I actually didn't want to spend so much time on the theory and then storytelling, so that we'll have like enough time for the hands-on. So I guess we can move to the hands-on now, right? So please, if you have questions, please drop them in the chat. Right, I can't see it now, but I would answer them like at the end of the session. Okay, so okay, I would like to share my screen, more like we share my screen. Give me a sec, please. Okay. Okay, I would like to know if you can see my new screen.
Yes, you can see your screen.
Okay, awesome. Okay, awesome. So yeah, if you're going to be following, which I don't think you're going to do, because first of all you have to have Python installed, right? And you have to install this tool called Anaconda. Let me see. Okay, what's going to happen is I'm going to share a GitHub repo, which would contain my notebook, my slides, the data set I'm using, and every other material you need. So if you would like to practice this on your own, right, so you can always do that. So as I said earlier, right, Pandas is an open source data analysis tool, right? So it allows you to just kind of wrangle your data the way you like, right? Do all sort of explore, without being confined to writing formulas and all. So, and it's actually easy because it's built with Python. So just like you write your normal Python functions, right? So you can do that with Pandas too. So if you want to get started, you have to install it. So you can install it with pip for those who like pip, or you can just install with conda. So conda is full name is Anaconda actually. So it's like an environment that comes with a lot of packages, right? That allows you to do all sort of let me put it this way. So it's an environment, right? Like a kind of big IDE that contains IDEs, right? So in Anaconda now you can have this is what they call a Jupyter notebook, right? So this so this is where you can write all your Python codes and all, and kind of do everything, anything code you want to do. So it's not only doesn't only come with Jupyter notebook though, it comes with Spider and what's the name, and all sorts. Actually, I can't even remember, Orange, for whatever your data analysis or whatever tool you want to use and all. Okay, so let's start anyways. So after installing Pandas, right, the next thing is, so you want to import it. I'm sure, okay, let me not assume that. So you're probably wondering, why am I importing NumPy? So NumPy is a kind of a, would I say, statistical library in Python? Yes. So Pandas and NumPy kind of go together, and not like I cannot use Pandas without NumPy, but then there are some functions that I want to call that I need NumPy for, which I'm going to show you also. So to check the kind of, okay, let me run this. So I already have Pandas installed, right? So imported that, and now you can see that the version of Pandas I'm using is 1.41. So now Pandas has its own data types, just like the way NumPy has its own data types, just like the way Python has its own data types, and every other programming language, right? Well, Pandas data types are actually a bit different. So it doesn't mean that there are no floats or integers or objects or categories, with Pandas. No, it doesn't mean that doesn't exist. It only tells you that Pandas recognize basically just three data types. So your data is either in form of a series, in form of a data frame, or an index for Pandas, right? And I would explain, right? Since my camera is off. Okay. So now this is a simple example of a Pandas series. Now I called NumPy here because I wanted to create in Excel. Imagine this in Excel, right? You're seeing an empty code, okay, let me not say code block, an empty cell in Excel, right? So that's the same thing as np.nan, that is, create an empty cell for me, right? And remember when I was explaining that this nan means it's empty, right? There is no value in it. So that is how Pandas recognizes its own. So this is a simple series, and now a series, now this just looks like a column in Excel, right? So this is just a column, right? So this is how to create this Pandas series. All you need to do is pd.series, then whatever you want to be, whatever you want to put inside the Pandas series. So now this is 2.0, 3.0, 5.0, and all, right? So I created the Pandas series, assigned it to a variable called data, right? And now data houses this column or this series. And the awesome thing is that I can also customize the index. So now what I refer to as row heading the other time was this 0, 1, 2, 3, 4 here, right? So this is like the index of the column, right? So this index by default, right, is between 0 to whatever the last data stops, right, -1. So if it stops at position maybe 167, probably is the 167th element, right? So it will be 0 to 166. So by default, but then I can customize it myself and then change it to whatever I want, right? So here, for example, I changed it to A, B, C, D, E, and F, right? And I can access a single element in Pandas. So let me say, okay, I want the element at index B, right? So the element at index B is 6.0. Okay, so this is what's going to give me. So if I want the element at so just 5.0 here, so that's what it's going to give me. And mind you that this F here represents the index. So assuming the index was to be a number, right, it's still the same way I'm going to do that. So there are actually a couple of ways you can create a series. So the first way I created a series was by passing in a list, right? So this is a list. This is a list in Python. So you have it's noted with square brackets. So that's one way. And the other way is with a dictionary. So this is a dictionary because it has curly braces, and then it has a key, and then it has a value. Now the difference between creating a Panda series with a dictionary and then or with a list is that for dictionaries I don't need to pass in the index already. It uses the key, which is this one, the very first one before the semicolon. It uses that as the index. So you can see here Abuja 34567. Then you can see California as 67893. You can see Lagos, you can see Florida, Alaska, And I said name here because I'm giving the series a name, just like naming your column. So basically the same thing, just like in Excel, just like I'm giving the column a name. Unlike here, I didn't give it a name, but here I'm giving it a name really. Okay. So this is like another way to create a kind of special dictionary, like special Pandas series. So now just like a quick summary, a series is like a column, right? And then there are multiple ways of creating a series. So you can do that from a list. Another way I didn't mention is array, right? So you can also create that from an array. And then the third way is dictionaries. Okay, so let's talk about data frames. So data frames are like, as I said earlier, they're like the worksheets, but we are going to just be talking about a very small part of it. So it's not like we are dealing with 1 million rows, right? So we're going to deal with just small size data frames so that we can like understand better. Okay, so what I want to do now is I want to create a data frame containing a dictionary of lists. So now, maybe if you are asking how would I know when it's a series, or how would I know when it's a data frame, right? So Pandas has its own keyword for creating a data frame, which is bd.dataframe, or like series. So now if you pass in a series as a data frame, like a value for a series, you pass it into a data frame, Pandas is going to like accept it, but then just going to create like a single column for you, right? So data frames can occupy as many columns as possible, right? Just like you can see here, right? So there is name, age, sex, country, position, right? So it can contain as many, but then series can only contain one, right? So
Hello, Bunmi. So sorry, just a quick suggestion. I'll advise you turn off your camera because things kind of is dragging a little bit.
okay. Oh, sorry, I didn't know I was muted.
Oh, and you're on
Okay.
mute. Okay, yeah. Okay, awesome.
Okay. Um. So as I was saying, to create a data, okay, a data frame can take like a lot of columns, right? Or like a series. So a series can only take one column, right? A data frame can take multiple columns, just like a table. Okay. So now I'm creating a data frame also with a dictionary, right? And then the difference is like unlike the other one, the dictionary only took one value, but here you see it's taking like a list. So you can see Jake Benson, Mark Robinson, and all this, all listed as rows, right? And then age, right? You can see the list, they're all listed as rows. So if for any reason, right, they're they're all not the same. So they are all six, like each of them are like six six values, sorry. So each of them are like six values. So if for any reason probably I maybe okay, let me try to remove a value. So I did a mistake, right? And then I mistakenly omitted a value. Pandas is going to give me an error. So you're probably thinking it's supposed to like tell me that it's empty, right? It's going to give me an error, and then saying all arrays must be of the same length, right? So it does not automatically assign that non empty value to you. So you have to tell it that, oh, okay, I want this to be empty. So if I want it to be empty, I can just say np.nan, and then okay, it says, oh, okay, I agree that this should be empty, right? So that's also another thing with pandas. And you can view the very, so assuming you have like 100 columns and then you want to just view the very first 5. So pandas has a function called .head. So yeah, like view the head of the data, right? So it views the first 5. But then you can limit it to, if I want to view the first 2, right? So I specify 2, then it gives me the first 2. If it's 3, if it's 10, if it's 20, right? So just specify the value inside the brackets. And you can also view the last 5. So if that's what you're also interested in, right? Pandas allows you to do that too. And so let's do some filtering. So let me assume you want to get only the names of people, right? In a particular, probably in a particular data now. You just want to get the names of the people there, right? So you can do that by calling the name of the data frame, then specifying the name of the column. So the column name is name actually, let me show you. So this is how the data frame looks like. So you can see that the column actually is name. So I want just this column, so I can specify it like this. You can remember in series, right? Series 2, when I was trying to get a single row, right, I specified this. Now the difference between series and data frame is that if I try to if I want, maybe I want to like get a particular row now, I can't call it this way, right? Because by default, this is for getting all columns like series, right? So this one is for getting columns. I can either specify the name or I specify the position. So if I say df name 0, okay, sorry, there is no column. If I want to specify the position, I have to use dot lock or dot lock. Sorry. Oh, sorry. Dot lock 0 now gives me the first row, right? You can see it gives me the first row. Let me show you. Okay, which is Jake Benson 21 MUSACU, right? So Jake Benson 21 MUSACU. So you can see that to get the very first row, you have to specify .iloc, unlike series where you just have to call the position directly, right? So that's like the difference between data frame and series. So now let's assume I want only people from Nigeria, right? Because the data frame is more like employees, right? Their position, their country, and then their age and gender. So if I want employees from only Nigeria, all I need to do is the whole data frame, then specify the column. So data frame for the country column where it's equal to Nigeria. So in Python, double equation sign means equal to, right? So where the country is equal to Nigeria, and then it gives you the whole data set, but only those that reside in Nigeria. And so you can do that the same thing for USA, right? And so what if I want to filter it by age? So those who are older than 24, right? Or those who are older than 46. So the same thing, right? Just call the name of the column, then add your condition. So those greater than 24. If it's those greater than 40, right? There's only one person that is older than 40, who is Daniel Scout. Is 42, is a male, is Scotland, and a software engineer, right? So another thing is the if then logic. So I know in Excel, right? So let's say if this, then this, right? So if this condition is fulfilled, do this, right? So also you have something similar to in Pandas. So but for that you're using the mp.where function. That is where the age is less than 18, you give the person 18, call the person 18, or else you call the person an adult, right? So I want to create a new column. So if the person is less than 18, tell the person that you are still a teenager, right? And if you're older than 18, I'm calling you an adult, right? So, but fortunately, in our data set, right, or data frame, no one is below 18, so everyone is above 18, right? So they are all adults. So this is like another way of creating another column based on the condition of another column, right? And you can actually use more than one columns. So by that you have to like add an or function, if this or and, you know, to get your to create whatever you want to create. And another exciting thing is that you can actually create you can export your data as CSV. You know, we created a data set, right, in using pandas. So now we can export this data set as a CSV file where we can use it in any other, you know, tool we want to use, or use it as any other thing we want to use. So maybe you're done with your analysis and then you got the data you need, and then you need to export it, right? So you can just do that like easily with df.csv, employee.csv. Then this index equals to false is not always needed. So let's assume you don't need this index, like this 0, 1, 2, 3, 4 here. If you don't need it, then you can say index equals to false. But if you need it, then you can just delete this, right? So it's just based on your needs, basically. So so let's actually kind of try this out with a kind of real life data set, sort of, and then see how these steps make sense. So I'm going to work with the Titanic data set, right? This one is like a easy peasy data set where you can just, so if you want to check it out, let me kind of post the link in the chat. Mm, sorry, I guess that didn't copy. Okay, so for those that want to check it out, the link is in the chat, right? So now the beautiful thing about pandas too is that pandas works with a couple of data types. So pandas works with JSON, pandas works with Excel. Yes, pandas can read Excel files. Pandas can also read CSV files. There's also this other type. I'm trying to remember the name, but it's not all that common. So probably the common ones you're going to be dealing with really is CSV, Excel, and probably JSON. Yeah. But then real life data sets are not always in CSV files, right? They're not always in Excel files, right? You have to like query them, then you export them to the formats you're comfortable with, right? So that's just like a disclaimer. So so to import, since the Titanic data set I'm working with, it's in a CSV format. All I need to do is pd.read CSV titanic.csv. That is the name of the file. So the file is in the same directory as my notebook, right? So that's why I can just call it like dot name. So assuming it's in a particular folder, I just have to write the directory here. But because it's here, so I can just call the name directly. Okay. So first of all, we want to view the first 5 rules, right? So you can see that it has this column: passenger ID, survived, B class, the name, the sex, the age, SBSP, patch, ticket, fare, cabin, embarked, right? So these are like columns. These are all columns. This is a data frame, right? So when pandas reads a file, it automatically converts that file to a data frame. So you don't need to say pd.dataframe, right? It's a data frame already. So pandas reads whatever file, then converts it to a data frame, and then you can begin to do all the wrangling and manipulations you want to do. Okay, so now you can also check the size of your data, or you say the shape of your data, right? So how many rows, how many columns, right? All you need to do is just call your data dot shape. So you see you have 891 rows and then 12 columns, right? And for it's a good practice, because the more you begin to work with pandas and all, and then you kind of get lost in your analysis, like you're so engrossed digesting and then understanding your data, right? You tend to make mistakes, and it's always a good practice to copy the data frame, because you just in case you want to kind of undo, right? You don't have to like start running um the whole data set again and again and again. And sometimes what if you kind of have just like one data set, and then you tampered with the original? You don't want that kind of situation where the change will be permanent, and you lost a lot of data. So it's always good to kind of create a copy, right? And then work on the copy. So when you are comfortable with the change, you can now apply it to the you may not even need to apply it to the original, right? You can just keep the copy and then keep the original, and then use the copy for whatever you want to do. So to do that, you can just do dot copy, right? So it's plain English basically. So you can also check the data information using the .info. So now, what is the .info? So the .info gives you a summary, just a quick summary of how your data set looks like, number of rows you have, the number of columns you have, the data type of each column, if you have missing values or not. It tells you also the memory usage, right? It tells you the range index. That is, oh, you have, yes, you have like 891 rows, right, between 0 to 890, a total of 12 columns. And then you can see here in the non-null count, that is the non-empty count, rows that are non-empty, you can see 891, and then you can see 714 here, which tells you that, oh, some of your columns are empty, which is the age column is empty. And then it tells you the data type, but I don't think your age should be point, right? You should, if you're 24, you're 24, not 24.5 or something. So that tells me as a data analyst or scientist that, okay, I need to do something about this, right? I need to change data type to be integer, right? And then you can see objects, right? You can see float. These are just the various data types you have. Then the describe just gives you a statistical summary. So info gives you like an overview, but the describe just gives you like a statistical summary of your data, right? It tells you the count, the mean, standard deviation, minimum, maximum, 70th percentile, 50th percentile, 25th percentile, right? But it does this only for the numerical columns. So it does not do this for categorical or columns with strings. It only does this for the numerical columns. And then you can also drop a column, right? All you need to do is just call the dot drop. So as you can drop a column, you can also drop a row, right? And the only difference is calling axis equals to 1. So axis equals to 1 means drop the vertical, right? Then if you don't specify axis equals to 1, by default axis equals to 0, which is the horizontal, which is the row, right? So by default, if you don't specify axis, right, it drops the row. But then know that there is no row, or would I say index title, right? There's no index here that is called passenger ID. So if I try to run this, it's going to give me an error. Okay, so let me try to do this. Okay. So it gives me a key error, right? Passenger ID not found in axis. That is, there is no index called passenger ID. basically. Oh, okay. It's giving me an error because I've dropped it already. So let me try to mm, okay, let me try to rerun that. That's why I say it's always good to have like a copy of your data so you can like redo it again, not having to like rerun again from the scratch. Okay, so now data again, right? So oh shit, I have to sorry. I ran it twice. Okay, good.
No problem.
So now
Take your time.
okay. So now you can see that passenger ID is no longer in this data set, right? So now I did something here which is in place equals to true. So now in place equals to true means let this have effect on the data frame I'm working with, right? So let this be on the data frame I'm working with. So if I don't say in place equals to true, something else I can do is to say data temp equals to, I can just say so this equal to this, right? So assigning, if I run this without saying in place equals to true, it's going to return this to me, right? But then I'm now taking this and then adding it to a new variable I call data underscore temp. But then to avoid all those typing stress, I can just say in place equals to true. But then not all pandas function has in place equals to true. So there are sometimes you need to um do it the other way where you have to say something equal to something, right? Or then say in place equal to true. But then how would you know which one is it? Well, if you're unsure, you can just type help then the pandas function, and it's going to let you know if it allows in place equals to true or not. So you can also check for the missing values, right? So you want to know the amount of missing values your data set contains. So all you need to do is the data frame dot is na, that is this column none, does it contain an empty row? Yes, right? If yes, give me the sum, basically, right? And then so since there is no one here, you have 000. But then when you get to age, right, you see 177. So it has 177 missing values. Cabin has 687, and impact has 2, right? So you can decide to drop it, right? So you can drop multiple columns. All you need to do is, unlike the first one, you just need to like make them a list. So like you're dropping a list, right? Add your square brackets. If you do not, it's going to throw you an error. So you add your square brackets and then you're good to go. So you can also drop rows, as I mentioned earlier. All you need to do is just to drop indicate the position of the row, right? So I want to drop row 2. So if I drop row 2 and I view, you can see that there is no 2 again here, right? So you have 0, 1, 3. So you can do you can also drop the rows too. Then you can check the number of columns you have, the names. So let me assume that you have like up to 86 or more than 86 columns, and then you are just looking for a particular column. You cannot see the whole 86 at once, right? So you can just call the column, and then you can even add a function to say if maybe you know that the column starts with A and then somewhere has B inside, right? So if A in this column, right? So return the column. So it's to give you all the list of columns with A in it, right? So that can kind of filter down your search. And then you can list the columns, you can also list the index. You can also rename columns too, right? So it has the dot rename function that helps you to rename column. So you can rename column sex to gender, right? So remember, let me show you the original data set. So you can see sex here, right? Then you have male, female, male, female, right? So you can change it to gender. Usually this is very, very important if you have maybe your naming, right? You have like gender then space. This it can be all like, let me say sex then space. It can be very, very annoying because you think you actually typed the correct thing, but then you don't know that there is a space at the end. That's very annoying. And then you keep finding out it's saying key error, that is the name, column name is not in the data frame, whereas you forgot to add a space. So you can change the name here. This is actually not the only way to do it. Like there are actually other ways, but this is like an easy way, right? So you can also select data sets based on their data types, right? So I want to deal with only the ones that are objects, right? So I want to deal with the ones that are strings alone, right? So you can filter them by specifying objects. Then you can also if you want to deal with the ones that are maybe you want to deal with everyone else except objects, right? So you just type exclude, right, equals to object. Or if you want to deal with everyone else except a particular one, right, just exclude whatever that one is, right? So you can also deal with floats alone, you can deal with integers alone. Like, so instead of you calling each name and then assigning them to another variable, you can just call that like one line of code. Then you can also select you can select values in a particular column, like in a particular range. So what this does is that, so select the column in position 0, right? The first 5 rows in position 0, basically. So this is position 0, which is the first one. Python counts from 0. So survive, pick the first 5. This is 0, 1, 1, 0, 0. So if you come down here, you see 0, 1, 1, 0, 0. So it picks the first 5 in position 0, right? And if you are not comfortable with positions, you prefer to use names, right? So you can also specify the column name, then list the first 5 elements, you know. Then you can also something I actually find very interesting is the duplicates. So you can add the duplicates, you can remove duplicates, because duplicates data are like I don't know, they're like pests in your data, because it's just like probably someone is trying to, maybe someone tried to book an hotel, then person made payment once, so maybe the payment kind of failed and the person tried again, so the data entered twice, but then I just need to know that, oh, you booked this hotel, right? I need your data once, right? But then it's entered twice, so what should I do? I don't have to sit down and then start manually going through each and every column to be seeing, looking for duplicates. I can just append, like, sorry, I can just drop the duplicates by calling drop duplicates. Like, it's just searches for all duplicates and then drop them. And then you can also check if they are duplicates, right? So all you need to do is to call dot duplicated, so it gives you all the duplicates, and then you can decide to do whatever you want to do with it, right? So let me just try to be fast. So here also you can select columns, or you can select your data frame based on a specific value, right? So select, give me the data frame, right, only for people in P class 1. So I want to see the data of only people in P class 1, right? Or you want to see data of only females, or you want to see people data of people in a particular range. right? You can also do that with pandas too. And also it's not just one, so you can say probably people in let me say give me data based on values between 1 and 0, or sorry, values with 1 and 0. So maybe in this P class here, right? So I think P class has 0, 1, 2, right? So it's going to return values with 1 and 0. If we check this one, just to tell you that okay, it's going to give you 1 and 0. There's one part I really want to explain, which is the group by, which is like very, very powerful or important, where you can kind of aggregate your data based on a particular data. Based on a particular column. So there is this column 6, right? And then I want to count the number of passengers using their ID, right? So how many females, how many males? Give me that summary. I can do that with data.groupby, right? And then I can also find the mean age of females, right? The mean age of males, right? Just call data.groupby, right? And then dot aggregate. And then I'm aggregating it by what the mean. I can call it by the maximum. Give me the maximum age of male. Give me the maximum age of female. You can also do that. Group by actually has like a whole lot, but then I cannot cover everything in just like 1 hour and all. And then the very, very last part is how to merge 2 or more data sets together. So pandas also allows you to merge 2 or more data sets together. So there is another data set called tips.csv, right? And what I want to do is I want to merge Titanic renamed, right? So what I did was I want to merge this data underscore temp that you used, right? I'm exporting it to CSV, and then I'm importing it back, right? And then I want to merge it with the tips.csv file, and I want to merge it on gender. So you can merge 2 different columns, two different data sets together on a particular column, right? All you need to do is to specify the column you want to merge on, and then how you want to merge it. Do you want to merge it on the left? Do you want to merge it on the right, center? Do you want an inner join? All these kind of things. You actually have all these variables together, like, so you get to choose the one you want to do. Yeah, basically. Well, I guess that's all. That's what I have now. Yeah. So thank you so much.
Awesome, awesome, awesome. So okay, Bunmi, someone asked that the file for today's presentation can it be made available?
Yes, I would share a GitHub link now.
Okay, yeah. So you can also put the GitHub link on the chat box, something like that. Okay, so everyone has been giving you comment. Awesome, 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 awesome. So also the recording we made available. So I'll put a link to the recording. So we'll put the recording on our YouTube channel.
Okay.
Yes. Oh, thanks. So you guys can just go and copy. You can fork the repository or something they call it. You can just fork it on GitHub and copy it and do whatever you want to do on it. So yeah, I actually like the part of your merge. I know there was time I was doing data manipulation. You merge with you do a merge with Power Query. You join with SQL. You merge with Python. Like everything is just the same. It's just different syntax and everything. So it's nice. I really appreciate it. Thank you. So if you have any question, can you put it in the chat box below? Any question? Any question? Anybody? Okay. So Bunmi.
Yeah.
So remember the question I asked you at the end of the section? I said you're going to answer 2 questions first. Okay, someone else is up. Okay, and that's Agbola. Okay, let me promote you as a speaker, Agbola. Just give me a second. So, Agbola, you can speak now. Unmute yourself and speak.
Thank you very much. Can you hear me?
Yeah, we can hear you loud and clear.
Yes, thank you. I appreciate the speaker and I really enjoyed the training. My question is that as I'm looking at this analysis now, which is with Python, we also have another maybe many tools for analysis. I want to know the uniqueness of this Python, especially using Panda. What is unique to this one? Because the way I'm seeing it, I've used R before, so I'm following this one too. So and there are some Power BI also, something similar, Excel, like that. What is unique to this one? That is my question.
So, Bunmi, we help us out with the answer.
Okay. Thank you so much. Well, first of all, of course, there are like tons of libraries and tons of things you can use really for analysis and all. But the thing about Pandas is, so first of all, is that it's beginner friendly, right? So if you're planning to go into data analysis and all, like you most likely come across Pandas if you're using Python. And then Pandas was built on Python, so you can like easily integrate Python functions with it. So it's not like you have to like be doing extra stuff. So it was built directly on Python, so that makes it very easy to use and all. There are actually other libraries that handle would I say larger data sets, right? Talk about PySpark and all. Like they all have their own use case and what they are used for, what they are very like what they're actually meant for. But for beginners, right, people that are getting started and people that maybe want to start data analysis, right, Pandas is a good option for you because it's actually beginner friendly and all. Yeah.
Okay, yeah. I think she said all already. She said all already. But for me, most times I would say mine it has to do with preference. Because for Python now, there's sometimes I might be doing data cleaning with Power Query or Power BI or whatever. And there's some specific things that Power Query can't do that. You have to use Python to do it. And you can see now Microsoft has kind of integrated Python inside of Power Query for data cleaning. So it has its own advantages about that. So there can be some kind of data that you might not be able to use Excel or Power Query to clean, but your knowledge of Python pandas, it helps you, makes it easy. So thank you. So Bunmi, the 2 questions I said I was going to ask at the end of the section. So question number 1, can you tell our guests, like our audience, how you started your own data analysis journey? And question number 2, what advice is there for people just starting out in the data space?
Okay. How I started my data analysis journey.
How you started the analysis journey? Yeah.
Okay. So when I started out, I didn't know if I wanted to be a data analyst or data scientist or whatever. So I kind of saw this training in school, and then I was like, I didn't want to go without learning new skills, so I hopped on it, and then it was just a week training. So the first day we were introduced to what is matrices and a lot of math. So it wasn't really start coding instantly. So we did basics of matrices and I was like, okay, I think I'm enjoying this class. Then day 2, we're doing a lot of data cleaning and then I'm like, I think this is not for me. Okay, and the theory we're doing machine learning, I'm like, okay, I think I haven't understood what data cleaning is. And it was more like a rush class and all. And so that was how I started. But then I actually found it interesting. And then I started disturbing a lot of people who I took as mentors. And I read books. I was not really a fan of watching videos. I get bored because that's just me actually. I get bored watching somebody writing on the board for hours. I prefer to read books because I kind of imagine and do a lot of things in my head, right? So, and that was me, and that was how I started. And so from there, I moved to building projects. Then I would write about the project and then see what other people have to say about it, right? And then hear feedbacks, like what do you guys think? And a lot of criticism, and then I'll get better. And so that was basically how I started. So I would not really say I took the data analysis part, right? So because I didn't really see myself as a data analyst. More like I saw myself more like a data scientist. So I say I took the data science part. Yeah.
Awesome. So that's how you started. But what about advice you have for people just starting out that how to go into either the data science or the data analytics or data engineering or anyone in the data business analytics, anyone? Like what advice do you have for people just want to start
Okay.
out?
Okay. So I know what people will tell you is probably go and watch YouTube videos. Well, you can probably watch YouTube videos, but it's tiring. Actually, gets very tiring. Like I'm just starting out in this field, and then you're telling me to watch YouTube videos. I knew YouTube videos were there, right? But what I would say is get a learning path because you would get confused because there are like too many materials and too many things. If it's possible for you to get a course, please do get a course. Like you need a guided learning path. So that is very, very important because that is how you can be able to like measure yourself like, okay, am I closer to being a data analyst or what else do I need to learn, right? So that's why I'll really advise you get a learning path. Then if you can get the mentor, good for you. If you cannot, it's not like I won't say it's something very compulsory for you to do. If you can get a mentor, good for you. If you can't, continue your learning path, build projects. Yes, so it's not just sitting down watching Udemy or watching Coursera and then having everything in your head. Learn to try out, even if it's just typing line of code, right? It sticks actually, and it helps because if you're stuck, you kind of remember the time you were typing something, and then you know the notebook exactly to go and look for, right? So um get a learning path, right? If you can get a mentor, good. If not, no problem. And also try to build projects. Try to code. Don't just sit down and then read. Yeah, basically, that's my advice.
Oh. So thank you very much. Thank you. So the video will be made available on our YouTube channel before the end of tomorrow. So our next session is coming up by 6. So let me just put the link. So by 6 p.m. we're having Power BI section. So let me just share my screen. Just a second. So our next session, I'll be taking the next session. I'll be teaching you guys how to connect Power Automate to Azure SQL database. So for some of you that might be interested, so by 6 o'clock, we'll be doing this by 6. And also thank everyone for attending out to this section. Also, thank you, Bunmi, for honoring our invitation. Really appreciate.
Thank you so much.
So thank you guys. So we'll see you guys by 6. And for everyone that might not be able to make it, have a lovely week ahead. Bye, guys.